Nuclear decay. Gold 196 has a half-life of 6.2 days. How much of this isotope will be left after 31 days, starting with the sample of 400 grams? We'll demonstrate two ways to solve the problem. One is the brute force method. We will make a table with the elapsed time and amount of the substance present at that time. We start at 0, always a good time. This is when we first have the gold 196 atom, and then write down one half-life. Well, that's going to be 6.2 days. Two half-lives will be twice that, or 12.4. Three half-lives, 3 times that, 18.6, and each time we're adding 6.2. So 18.6 plus 6.2 is 24.8. Add another 6.2, you get 31. So that's the left side of our little table here. Now you fill in the amount. We started with 400 grams when we first were delivered this particular isotope, and then after one half-life, which is 6.2 days, you cut it in half. So I have 200 grams. Another half-life, cut it in half again. Another half-life, getting a little monotonous, going down to 50, then to 25, then down to 12.5, and can we stop? Yep, because what did the problem ask for? How much was left after 31 days? So the answer is 12.5 grams. This table method is slightly longer than the one we're going to do next, but it also works if you are given the ending amount, here, and you want to know this, how much time has passed. In that case, you just go back the other way. And here's the algebraic way, where y is equal to x over 2 to the n. N is the number of half-lives, x is your original sample size, and y is your sample size after n half-lives. Now where this really helps, where the table doesn't do such a good job, what if you don't have 5 half-lives? What if you have 5.3 or 6.8? Then the table method won't work, but this will work. Algebra always works. So in this case, we have to find the number of half-lives, so we divide the total amount of time that we want to elapse, and that's 31 days, by the half-life. So in this case, 31 days, 6.2 days, we have 5 half-lives. So that's pretty cool. Here's our equation. Y is x over 2 to the n. We know that x, our original, is 400 grams. We have 2 raised to the power of 5 because we have 5 half-lives. And this is where if you had 5.2 half-lives or 8.7, just plug that in. And certainly don't need you to do that by hand. You won't be able to. Just plug it into your calculator, right? 2, put that caret sign, and then 8.7 or 3.8, whatever the number of half-lives are. And in this case, we get 400 divided by 32, and we have 12.5 grams is how much you have left over, just like the table method. In this case, the equation method is shorter, especially if you have a large number of half-lives or a non-integral number of half-lives. However, this method can be tricky if you're given the ending amount and if you have to solve for the number of half-lives n. Then you have to do some trickier math. Obviously, it can still be done, but you have to choose which method works for your situation. And we've given you 2 examples here. Right, so this one, use algebra, and then this one, the table method would probably work better for you.